One, two, one, two, one, two, one, two, one, two. Woo!
Hello guys and welcome back to this one. So today we are going to be looking at the debugger tool as promised, and we see how the data moves through this specific function and still returns us the Inorder Traversal as we wanted in the first instance. Yeah, so let's get this cooking. So we see that we are the head of the node. We've defined the node. We are at 4 as seen here, right? You take it out of the road. So so we see that we are 4 and we see that our current is not none, so we are golden. So let's go. Now we say if current dot left is none. So is current dot left none? Let's see. It's not none, so the guy basically skips over it with the quickness and shows us the current has a value right here. I think you should do that here, but yeah. um we say else predecessor equals to current dot left. So we begin to transverse. So I think we should have a predecessor defined. Now we see our predecessor here. It's holding 2. So we go down to, so predecessor to the right. So predecessor should be change it to 3, and its left and right nodes are none. So we see here that right node, if right node is not none, basically it is none, and predecessor current is predecessor right is not current. So basically this one has already disqualified it. Yep. So um uh so we could move through and we see that predecessor is remaining at 2 for this instance, right? So let's see. I don't think can this guy, okay. Yeah, so we see that our predecessor right is 3. So our predecessor is 3. So our predecessor right will still be none. So because we don't continue, we don't this situation was not met. It's not. It's so predecessor right was none. So basically at that instance we had to stop because this while loop cannot continue because the predecessor right is none. So if it wasn't none and it was pointing to current, so we say while predecessor right is not none basically, and current and predecessor right is not equals to current. So we should at that instant to stop the while loop. So right, so we stop the while loop in sense when the right becomes none and when the right is current, right? So it says while it's not current you can continue, but while it's current you need to stop. So yeah, having defined that, we could see that we can stop while it is 3 and we have a none right here. So it says if predecessor, I think this read my guy, the right is none. So it is none, so we can choose this conditional. So we say predecessor right is equals to current. So we point it to current. So the right which was known, we point it to current. So you can see our current becomes a predecessor right. Let's go to predecessor, yeah. So we see that it is still 3. So by the time we iterate into I don't know if it becomes not yet. So we go through this now. We can see that the right, you can see the right here, it becomes 4. When we move to the right again, I don't think, yeah, so it becomes 4. So the predecessor is still 3, but its right is 4, and we point it to the current, which is 4, which is what we're pointing into. So we now say current equals current the left. So we move to the left. So current now becomes current left, which is, let's see, I don't think it moved. It's moved yet already. So we see that the value of current is now 2. So we continue. We go to the top. So we say while loop is still a value, is not none. So we continue down. This guy is still not met because current dot left is not none. So we continue and we get to a point where predecessor is now 1 because our current is 2. We moved predecessor to the current dot left. So we see current as 2 and then its left is 1. So, and that's what we move predecessor to be. So we say while predecessor right and predecessor right is not current. So what is predecessor right? So predecessor right at this point is none. So we break throughout this loop and then we say and predecessor right is not current. So it's obviously not current. So what do? You see predecessor right is none. It is definitely none. Let us keep through. It's definitely not. So we are going to point it now to current. So we see we point to current. So you see that the right now becomes a value, and the right is the value of 2. So we pointed back to 2. And then what do? We say current dot left. So we move to the left, right? Which will be 1. Let us see if we updated. Not yet. So we move. So we will see that our current at this instance is now 1, right? So basically right now we are here. It's our current now. We've done the whole, picking this guy, having him point to this guy, picking this guy, having him point to this guy. Now we have this guy over here. So that's where we are from the graphical illustration. So we move continuously again, and now we say if current the left is none. What does that mean? Print. So if the current the left is none, so if our current is this guy, that the none, the left is actually truly none. So we now finally meet this conditional. So we see we enter into it and we print out current the value, which is 1, right? We print out that to 1, and basically we say current the right, which is this is so we have our current the left to be none, and obviously we say while that is the case, if it is none, then we should print out our current value. So this is our current value, which is 1. So we could begin our printers process again. So we have 1 here, and then we say current dot right. So current dot right now points us back to 2, right? And then we could see how that does that. Let's see if we pitch it up here. So you see that our value is 2, and then so let's see. Okay, let's go down. So as we step into 8, we see that that if loop is finalized, our current is what? Back to 2, so it's not none, so we can continue transversing. We come back, current on left, is it none? Nope. So we skip over. Now our predecessor is current on left. So what does that look like? So our predecessor is current on the left right here, right? So we put that there, and then we say while current the right, right? And current the right is not equals to current. So basically current the right, let's push in. Now current the right at this point is not none, and current the right, but current the right is equals to current. So we see that this conditional is still not met because right here we have the right pointing to current, so we have to skip over it. Now is current the right none? No, it's not none, it's actually current. So what do we do? Yeah, it's actually current. It's current the right is pointing to 2, which is current at the point. So we say if predecessor, so we now say predecessor to the right. You can see that we get to the else statement immediately because that's the situation right now. Predecessor to the right is equals to none, so it basically takes this guy again and points it down, and then again print current value. Yep. Print the value, which is 2. That's the value of this is 2. Current right now is 2, and then we go to current right. The current right, you can see that here. So the same stuff again happens, right? When we go down recursion 3 again, we will see the current is now back to 4, and then right. Wait a minute. Current. Okay, that's the first instance. So this is where we are talking about the current value is now 3, as we can see here. So we go down, and then we see is current on left none. Yeah, actually current on left is none. So we enter into that, we print out 3. We print out 3 and we move to current on right. So let's see. So we print out 3, 3, and then current on right. We put this up. First, we move to current on right. That's correct right there. Now, yeah. So after doing that, we will go back to the top where our current will be 4, right? And if our current is 4, we go down. Current the left, is it none? Yes, current the left is not none. So we say print with the current the left none. No, it's not none. So we jump over to the else statement. We make predecessor current or left. I think I've gone and forgotten this guy's head pointer somewhere. But yeah, I don't even know whether I think I erased it or something. Let's remove that. Take it out. Take it out there. So to left. So we do this guy to move down recursively down the tree to get to 3. And then when we get to 3, we will check if current or right is none. Is it none? No. So we go to predecessor right and we point the right from current back to none. And then what do? We say print current value, which is 4. So we add that to this guy. 4. And yep, we print it out. I think I'm not longer taking my video along. So yeah, so this is predecessor right equals to none. Print current dot value, which is 4, which is what we just did, and then we'll go to the right. So current dot right. So yeah, so we see the same again, and then we continue moving down the continue moving down the loop. So we just monitor everything from here, and then we see. So we see that our current is at 6. So we see that we move from 6 now. The predecessor is 5, and then we continue to say if predecessor right is none. So it's the 5 at the right of none. I think it does. Yeah, it has the 5. It's the right of none. It's right here. So we continue to say right predecessor right. So become predecessor current. So basically pointing 5 back to 6, and then we say current on left. So basically 6 comes to 5. So we see that here. So yeah, whatever. So 6 comes to 5. We continue down. The current left is none, it is none, so current value is printed out, that's 5 is printed out. So we didn't see our print out here, so we see that 5 is just printed out, and then we say okay, we got it up, we got the 6 creates the predecessor, which is 5, it creates 2 leads, and yeah, 5 is already the last bit, so we jump over that and we say if predecessor right is none. Predecessor right is none, so we also jump over that, and then we say predecessor right equals to none. So basically we are bringing the 5 that we are pointed to 6 back to 5, and then we go ahead to print 6, and current on right becomes then we go to current on right, we will now have 7. So that's just what we continue to do to get our final answer as we see here 1, 2, 3, 4, 5, 6. So using the debugger tool, we have also seen this solution come alive in a situation where we have it as so we can then boldly say that okay, yeah, we've gotten our values and this Morris transversal also works for this. So we're going to now go ahead in the next video to complexity. What is the complexity of Morris transversal? How was the data time complexity of this complexity? These are the questions we answer as we then go into understanding the values, sorry, the inner transversal and then the caveat I talk about that we're going to have very soon in the complexity. So that's basically for the debugger. So this now grounds the idea of what the Morris transversal is trying to do and how it helps us in the inner transversal. So yeah, see you in the next video. Just guys, bye.